Robbie, you good? Do you need anything else from me besides just keeping an eye on the riffraff tonight?
No, keep an eye on the riffraff is good. Yeah, I've practiced the run through a couple of times, and I thought, you know, I might be going back and forth, so it's easier just to control it myself and maybe do it that way. So
I found the last one I did, it was easier to run the slides myself, but you know, it is what it is. But I'm happy to jump in at any point to do anything if you need. So,
you know, I thought maybe if we maybe handle questions and answers via the chat, like we've done in the previous TechNets, that might be a good way to, you know, have them make sure that the people on the Zoom get their questions answered as well as people on the radio.
Yeah, that sounds good. I've got the chat window open, so if I see anything coming in, I'll monitor that. You break for questions, I can relay on the so.
Perfect. Thanks for your support, Jim. Great tech.
Oh, you bet. I appreciate your support.
Yeah, it's a lot of. I think this is a lot of fun. For me, this is fun stuff.
Yeah, I enjoy it too. It causes me to think. So, and it's good seeing everybody in here. I'm glad that people are making this a regular occurrence in the club. It's cool. So it's a lot of fun.
All right. Well, I'm going to make a announcement on the 2-meter repeater. So here we go.
All right. Good luck.
Okay, at some point when we start this, I'm going to probably share my screen, which has all my slides. You guys will be able to see all that. And as we progress forward, I may stop for questions and answers via the 2-meter repeater. But if you've got any questions, please refer those to James, AB1DQ, and he'll be able to take all of those questions and pose them. If you pose them on the chat, we'll make sure to get to them. If you pose a question via adding voice to the Zoom meeting, make sure you're addressing Jim and make sure he acknowledges you. So this is K1RCT about ready to start here in another minute or so.
We're getting a little background noise coming through somebody's open mic.
Yeah, it's mine. Nothing I can do about it.
Yeah, everybody else should mute except for Rob. Again, you know, try to put your questions in the chat or unmute if you get to, then just remute so we can hear what's going on. Anyways, have a good night, Rob. Looking forward to the presentation.
Everybody on Zoom can, whoa, that doesn't work. Let's not do that. This is K1RCT. I'll be starting the TechNet calling all stations, amateur radio stations. This is Kilo 1 Romeo Charlie Tango starting the Meriden Amateur Radio Club TechNet for February 18th, 2021. Our TechNet tonight will cover the topic of station grounding for the radio amateur. Anyone that would like to check in, please do so now.
KC1LYP.
Carry KB1DQ, James in Cheshire. Good evening, Rob.
KB1 FYL, Bobcat in Cheshire.
K1 JCF, Joe in Hampton. N1 BRL, Martin Wallingford. N1 GNV, John in Meriden. W1 DQ, John in Cheshire. U1U East Hampton.
KC1 OMP, Wallingford.
U1 KKF Bill Wallingford.
KC1 KQH, John in Cheshire.
Okay, everybody on Zoom, please mute yourselves. We got a little feedback there. Just want to point that out before I go on the RF. Okay, so let's stop there. I have via Zoom K1 LYP, John, AB1DQ on 2 meter, KB1 CIW. On Zoom, I have KB1 FYL, 2 meter. I've got Kilo 1 JCF, N1 BRL, N1 GNV, W1DQ, and NU1 University Ant. Via Zoom, I've got KC1 OMP, and also via Zoom, I've got W1 KKF, and I also have KC1 KQH. Any others?
KC1 DOY, Ted in Waterbury via Zoom.
N1 YLN, Ed in Waterbury via Zoom.
And
W-
YSM by Zoom.
Okay, Zoom stop. Zoom stop. Okay, I heard somebody on the 2 meter. What was your call sign again, please?
W.
You're going to have to speak up a lot louder than you are. I can tell that you're transmitting, but I cannot make you out your call sign. Okay, was not able to catch that call sign. Hopefully you can check in here in a few minutes. I also heard a few guys on Zoom. Could you guys repeat your call sign on Zoom, please?
W1 YSM, Ed.
KB1 GYZ, Bob.
KC1
Bob.
KC1 DOY, Ted.
N1
W1
YLN, Ed.
W1RJL, Rich.
A1SCI, Togi.
KC1 NQE, Sean.
N1 PFD, Dave.
Dave, what was your call sign again? N1?
N1 PFD, Papa Frank David.
N1 personal flotation device. Very good.
That'll work too. KF Bill Wallingford.
KC1 FDI, Dorian.
KC1, what was the F?
FDI,
Frank David India?
yes.
Perfect. Okay, via Zoom, I've got W1 YSM, KB1 GYZ, KC1 DOY, N1 YLN, W1 RJL, K1 SEI, KC1 NQE, November 1, Papa Frank David, W1 KKF, and KC1 FDI. Any others?
KE1AU.
Hold on, Zoom. Hold on.
KC1 OMP, Damien and Wallingford.
Okay, Zoom. I've got KC1 OMP. There was a couple of like 2 or 3 other guys.
Whiskey 1 Echo Delta X-ray.
W1EDX. Any others?
KE1AU.
E1AU. Hey, Bob.
WA1TRY.
WA1TRY. Hey, Rich.
Rob, I'm WB1GYZ.
What did I say? Oh, KB1, W1, WB1GYZ. Got it. Thanks, Bob.
KC1 KYH, John.
KYH, John. Got it. Any others on Zoom that I haven't gotten so far? You wouldn't know that, would you? You would be guessing, and that's okay to guess. Got a bunch. Okay, I'm on 2 meter standby. Okay, so we're getting ready to start our 2 meter TechNet. We've got all the call signs checked in that we can, and we'll check for a few other call signs later. If you're not on the Zoom meeting, I'll try to best to eloquate what we're seeing, but we're going to be covering station grounding for the radio amateur, the single point ground system. So moving forward. Definitions. What is single point ground? Part of a system designed for the protection of human life. RF ground is part of a system designed to enhance RF radiation or propagation. Protective earth, or PE. PE is a way to identify the purpose. Hold on a second. There we go. Okay, sorry about that. PE is a way to identify the purpose of a wire in a schematic. Protective earth. It's simply a definition. PEG, protective earth ground, what the wire in PE is connected to, usually by a grounding rod. Chassis ground, equipment chassis where grounding is made. Usually there's a screw or a bolt that's connected on the back of a device, or there's some place that you would connect the grounding wire to. A grounding rod usually was an 8 foot by 1/2 or 5/8 of an inch copper clad wire rod, driven into the ground to provide PEG. And neutral, which is the 0 volt side of an AC supply, the white wire in a commercial or residential building electric service. And another definition, the final one, is Cad weld, which is a method of making a permanent exothermic or weld of conductors. This is K1RCT. Any questions about definitions? None heard. I'm sorry if you guys hear a little bit of background noise. I've got that here. Discussion and topics. We will cover the protective earth ground, single point ground side of things in this presentation. We will not cover RF grounding side. The presentation will cover only the basics, enough to wet your whistle and create more questions. And finally, RF grounding, RF noise abatement, RF in the shack, etc. While important, can and probably will be covered in another TechNet or in a future presentation, maybe an activity meeting or some other TechNet. My next slide covers safety ground, protective earth ground, and earth. There are a few ways that achieve proper safety grounding in your home. Most modern houses have a ground that comes in with the electric service. This is usually attached to the 100 amp or 200 amp service panel, whichever you've got in your home, which is your circuit breaker panel. While the neutral wire, the white wire, is usually connected to protective earth ground, it isn't always. Sometimes there are isolated systems, like such as in what's available in hospitals and whatnot. Never assume and always know. You have to know what you're dealing with. Never guess, never assume. Number 2, sometimes protective earth ground is connected via a water pipe bond or a clamp inside and near the service panel. This is true for the Emergency Ops Center, or OEM, at Hope Hill Firehouse. Believe it or not, in the utility room, their earth ground is connected to a water pipe, which is serviced by that little room on the outside of the where antennas are at. And still others are connected ground wire to an earthing rod or a ground rod driven through the floor of the foundation into earth. I have seen this in other homes and other industrial and commercial establishments. In commercial industrial installations, protective earth ground is usually picked up via the electrical service as it enters the plant or the building, assuming a 3-phase service. Older industrial installations may have grounding rods throughout the plant serving each machine. Regardless of which way a protective earth ground is provided to you, you must know which way it enters and how to proceed with your station grounding prior to installation. Spend some time looking over your specifics. Become the protective earth ground expert at your home. Your life may depend on it. And as I always say, never assume, always know, never guess. Never guess. If you're guessing, you're not doing yourself justice. Are there any questions via Zoom or via 2-meter repeater on safety earth definitions and what we're going to cover during this meeting? This is K1RCT. Nothing heard either way, so we'll move on. What is single point ground? In these 2 examples, all chassis grounds, protective earth, grounding rods, and electric service ground, or PEG, are tied to a single point. In our case at the EOC at Hope Hill Road, the service ground, which is the electrical service, and each piece of gear inside the shack are all brought out to the service box located on the exterior north wall of the building. I know a lot of you have seen that box outside. It's mounted to the building, and that's where all the business takes place of grounding. There, the ground rod and each braided wire are mechanically bonded to a copper plate using parallel connections. Feed lines are connected to ground by a polyphaser. That's a brand name. And what I really mean is coaxial impulse protector or lightning protection mounted on the copper backplane. The rotor control wires are connected to a terminal block, with each line connected to an MOV, a metal oxide varistor, connected to ground. Braking for station. This is K1RCT. What I've got up on my screen are 2 connections. There's a series connection on the left where you see 1, 2, and 3, which can be any type of piece of gear connected along a serial connection to ground. And on the right, you see a parallel connection where each piece of gear 1, 2, and 3 has its own connection to the same point of ground. What follows are illustrations of the 2 ways to connect an SPG system, parallel and serial. Can anyone guess as to which way is best? And is there a best? This is K1RCT.
I would guess parallel.
Who is that, Bob?
Yeah, yes, it is.
I'm sorry for coughing into the mic, guys. I keep forgetting I'm live on the mic. Okay, I've got 1 guess at the parallel connection. Anyone else want to guess? This is K1RCT.
I think they're equally good.
I agree.
I agree with Bob.
Well, I say that because if you lose the on the series, if you lose the ground, you lose all 3. But on the parallel, you lose 1, you still have the other 2.
Okay, there's some discussion on Zoom about some that agree with Bob, who agrees that the parallel connection is the best, and some others say that they're both the same. And I don't really think they're the same. The parallel grounding connection, I've got another slide up. Again, this exemplifies the fact that each piece of gear has its own connection to ground, the single point ground. Everything, including the service ground, which comes in from the electrical service, is grounded to that point outside of your building. What's the point of all this? To make sure that the station is grounded before anything enters the building. So the grounding rods outside, all these single point grounds are connected to a copper plate, which is outside. Everything is grounded to one point. The next slide has got serial ground connections. And in this particular example, you can see that in the red, there are identified ground loops which can occur. Why is that important? Ground loops are nothing more than voltages that are developed. It's like there's a resistor between the leftmost device, which is a desktop computer. The next device is an other station accessory, let's say like maybe an AB switch. The next device connected along the serial connection is a transceiver. The next device is a linear amplifier, and the last device is an antenna system tuner. Each one has its own connection to this serialized heavy grounding bus. Each one is allowed to develop a voltage between itself, which makes for a lot of noise, and it can make enough noise that you can hear it. The main difference between serial and parallel connections is a parallel connection has its own ground connected to a same point as all the others. Okay, I'm going to slide back here. I'm not prepared to probably discuss the benefits of one over the other, why one's better than the other. I'm a firm believer that parallel ground connections are superior to serial because they don't enhance noise like serial ground connections do. We can certainly get into that at a later date, but this is meant as an introduction to grounding your station, and some methods are probably better than others, and we should all probably educate ourselves that way. Any questions on parallel or serial ground connections? K1RCT.
Just an observation.
Any questions?
I have an observation.
Thanks, John. I appreciate the observation. I just want to handle questions right now. No questions. Okay, no questions heard, and we'll get to your observation, John, in just a few minutes. Design draft, utility poles. This is what we have in the backyard of the EOC. We have 3 utility poles or telephone poles going from left, which is the southernmost pole, and on the right, we have the northernmost pole. And basically, this is just a graphic representation of what we intended to install at the EOC before we got there. We had to submit these drawings that you're about to see to the Wallingford, it was the chief, plus his town electrician that they told us we had to give this to. So we had to draft these up, and this is just a very simple graphic about what we've got out back. Of course, we have more antennas than that now, but this is how we started. Okay, next slide. We have another design draft, which is basically how we intended to use the single point ground on the exterior of the building. It's along the north wall, and it's serviced by a 3-inch PVC conduit, which is buried, that goes out to the middle telephone pole and services all of the feed lines and rotor control lines that go out to all of the antennas that we have in the backyard there. It's a rough sketch. The only reason I really provided these couple of slides was to exemplify the fact that you should probably have your own plan to install your own gear, right? You should have it laid out so that you can refer to it, you can go back to it, you can amend it if you need to. But it's good to operate from the standpoint that you've got a plan. This is the plan you're going to follow through with. And regardless of whether it's perfect or not perfect, you're going to do this plan and you can improve upon it later. Any questions that we have so far? This is K1RCT. All right, John, you had a question about, you had an observation about single point parallel and serial. Go ahead with that.
Okay, go back one slide, please.
Here?
Yes, that one. Sorry, I guess I meant 2 slides. The thing you definitely do not want to do is a real serial connection where you go from one to the next, to the next, to the next, without that common bus bar, if you will. That's really where you get ground loops.
Right.
And you want to do what you show here would be minimum. I could see possibly benefits to the parallel, but you definitely want to have at least a common bus bar and not just go from one to the other in a daisy chain.
Right, that's exactly right, John. So John, N1GAV is pointing out via Zoom why you would probably not want a daisy chain type of connection to ground. And he's absolutely right about that. You know what, having grounds, even if it's serialized, is better than not having grounds. And we're talking about protecting human life here. The whole point of this discussion is protecting human life. If there's somebody operating a piece of gear and it sustains a lightning strike, you want to protect that person from the voltage that's created by the lightning strike. And you do that by using a single point ground system. Whether it's parallel or serial is not going to matter to the guy that's inside the shack when the lightning strike occurs. He's going to care that you had something there to help protect his life. So having something is better than nothing. There are some methods that are better than others. And we're simply, we've arrived at the conclusion we need a single point ground system. How you get there is probably more attributed to what you can afford and what you have resources for than anything else. There's certainly better methods than others, but this is a good example of why you need to really protect yourselves and through using a properly grounded station. This is K1RCT. Any questions so far by a 2-meter repeater? $55. Okay, the slide that I have up now is the Chris Sievert radio room, the CSRR, what I refer to. It's been dedicated as. What you're seeing are rough draft copies or sketch-ups that we had to provide to the electrician about what we wanted for our electrical service. On the left side, we have a view of the interior north wall. This is looking north. The wall that has a window, for those of you that are familiar. We did initially intend on putting a VHF station next to the window. We ended up not doing that. It didn't make the final cut, as you can see. But on the right side was what we ended up with for the HF station. The one rig on the left, which is labeled here as a CW rig, and is now the sideband rig, and the right-hand side is labeled here as sideband, but it's actually a CW. But what's important here is what's in red. These were the items we had to specify for the electrician to install inside the radio room. This is what we needed, what we felt we needed to install all the rigs and electrical gear that we wanted to install, and have it properly serviced by the electric service brought into the building. This is K1RCT. Any questions on Zoom about this schematic? Nothing heard. Okay, public service announcement. On to the next slide. These sketches were approved by the town electrician and the in Wallingford, town of Wallingford as well. So I guess we did a good job. We didn't have to amend this except for maybe one or two items here and there. The next slide is again the design. This is on the left what we intended initially on the north side of the building looking south. This is on the outside of the building looking at the 4 windows. We intended on putting a tower and a slab right next to the building. The single point ground, that little box on the lower left underneath the window, is actually in place there. And we intended on bringing all these antennas in through this tower, which we were not approved to put in there. So the tower is not approved at this point to put in there. We were told at some point we would be able to put a tower up there, but not in that location. The right-hand pictogram is the basically looking south from inside the radio room. That's the entry door. We intended to put a branch panel, which is a circuit breaker panel, right next to the door. And the electrician said we probably should put it elsewhere, so we did. That one also never made the final cut. So we had like maybe 2 or 3 amendments we had to make. You know, the whole point of this endeavor is have a plan, try to follow the plan. If you have to make amendments, you can make amendments. Okay, the next slide that I have is the actual radio HF bench that we have current day. It was taken in the afternoon or evening. We closed off some of the lights. It's got some backlight. It's a nice operating position. We've got 2 operating positions depicted in this. And this is the station that we currently enjoy if we were able to get up to the EOC. The left station is an FT950. The right station is an FT991A. The left station is affectionately known as the sideband station, and the right hand station is affectionately known as the CW station or Beep Beep Boys. We can do slow scan TV from the right station. We can do digital modes from the left station. So it's pretty versatile. We can share antennas from connections that we have in the middle between the 2 stations, but effectively this is a present day HF station. Any questions from either Zoom or 2-meter repeater? This is K1RCT. Okay, so what's coming up next are some completed entrance panels. So when you are on the outside of the building looking south at the 4 windows, you're going to see our single point ground. And inside that, you're going to see something like this. It's a big copper plate inside of a box. And inside that copper plate, you're going to see some connections. All of the coaxial lightning protection devices, or what I call polyphasers just for short, are depicted in this frame in these 3 different pictures by the red circle. Basically, you come in from the tower with a coax. They get fed into a polyphaser or some sort of coaxial line protection. And on the other side, it ingresses to the building. The next series of connections are in blue. These devices are protect line level devices like rotator controls. The devices that are circled in blue in my slides are protective devices. And the one in the upper left corner has these blue devices called metal oxide varistors. Basically, they're variable resistors. And each one is attached between the rotator control line and ground. And they're designed to conduct electricity beyond a certain voltage limit to ground and try to protect the device that it's protecting. But all of the other devices are also protective devices. And I'm not going to go into which type they are, but they're all designed to do the same thing. Protect the line level of the wires and the devices beyond them from a surge in voltage. The next series of highlights in my slide are the yellow or orange, which are ingress and egress routes and methods. In the upper left corner of the right picture, if you're looking at my slides, you'll see the way that it comes from the box through the wall to the inside of the building. Each one of these panels that you're looking at has some way of getting the coax and the control wire from this panel to the inside of the building, where it can do some good, like get connected to a rotator controller, get connected to an AB switch or a tuner or a transceiver, right? What you also see is in the bottom of each one of these boxes are an ingress route, or I use a gland. These guys are just using like a grommet, like a rubber grommet that's fitted to the panel. They're designed to keep the elements out of the box, keep bugs out of the box, and isolate the atmosphere from inside of the box. Any questions via Zoom or 2-meter repeater about the entrance panels that we've covered so far? This is K1RCT.
WA1TRY with a question.
Okay, go ahead, Rich.
Yeah, what would you recommend for a minimum gauge for that copper, how the thickness?
Are you talking about the copper plate?
Yeah, the common point copper.
Yeah, I used a 1/4 inch. All of the research I did before we installed at the EOC was, yeah, you can use something a little bit thinner, but I wanted something that I could drill and tap and actually secure without having to bolt it in. I wanted to be able to use a fastener that I could just screw into the device rather than having to bolt it into the panel.
Excellent, thank you.
You bet. Thanks for the question. Okay, we did have a question on Zoom, and we answered it. The question was related to the thickness of the panel. And simply stated, it was a functional decision to make a 1/4 inch panel so that we could drill and tap it and put a fastener in instead of having to bolt it in place. We're going to proceed to the components, and we're nearing somewhere near the end. These are the components you may need to develop your own single point ground system for your station. The size of your service panel will vary according to your need. The more antennas and rotors require larger boxes. At the EOC, the box that we have presently accommodates 5 antennas. It is 14 inches by 20 inches by 10 inches. And certainly smaller installations would use a much smaller panel. If you don't ever intend on having 5 antennas, you don't need a service box that's big. But in my slide, the service panel also has a sub panel, which is where I mount all of the copper products that go into a box. Now at the EOC that I have, and I've got one at my house, I use a full sheet of copper. It's 10 inches by 12 inches by about a 1/4 inch thick. And it's mounted to the subplate using an insulator. If you're looking at my slide on Zoom, you'll see in the upper left side, there's a smaller piece of copper that's attached to an insulator. I use insulators such as this. They're smaller than this one, but I use insulators just like that to mount that copper plate to the sub panel that's inside the box. The point of it is make it easier for yourself to service. Use a plate that's large enough for expansion in the future, but a plate that's large enough to handle what your needs are. Any questions about copper subplates or substrates or any of that conductive? You don't need to always use copper. You can use aluminum, but copper is probably a better conductor than aluminum. No questions, so we'll move on. Components, Ingress components. Okay, so if you're looking at my slides, you're seeing that there are 2 boxes with some glands that are servicing the box. Pretend you don't see fan openings, because we're not going to have a fan opening on the outside of a building. The point of this whole series of pictures is to point out the fact that you can populate a box along the bottom with glands. What is a gland? A gland is a hermetic electric cable conduit made of polymer or maybe metal, and it's designed to do 2 things. Essentially, it's designed to isolate the atmosphere from the box, but it does it in 2 methods. Number 1, it seals between the box and the gland itself, preventing the atmosphere from getting inside the box. And it also isolates the outside atmosphere from the gland itself. So when you put the gland through, when you put the cable through the gland, you tighten the nut on the outside of the gland, it seals around the cable and seals against the box and makes a hermetic seal into the box. This is the way you can seal every coax or every wire that comes into an outside service box. Are there any questions about how you access a box with a gland, or any questions about gland, what a gland really is? This is K1RCT. Oops, I just lost my battery. That kind of sucks. Sorry, guys, give me a minute. Should have known that. There we go. Luckily, I've got another transceiver ready to go. There we go. Probably should have brought my mobile rig inside the house, huh? Nope, no, I'm on that one. Now we're on that Wallingford. Okay, sorry, I lost my, oops. That's giving me a hard time tonight. Lost my 2 meter, my HT that I was using. Sorry, this is K1RCT. Any questions about ingress or glands?
KC1DOY.
Okay, we got a question via Zoom. Go ahead, Ted.
Yeah, absent the availability of these glands, could you use like a silicone caulk if you don't have too many cables going in?
Yeah, absolutely. The question is, can you use silicone caulking or some other device to try to seal up your single point ground? And the answer is yes, absolutely. If you don't want to buy glands, if you can't access them, it's certainly better than not sealing the exterior, the box from the elements. You always want to seal that box up no matter which way you do it. And I've certainly done that. I've certainly used some like Dow Corning 738 and other such type of RTV sealant on boxes such as that. That answer that, Ted?
Yes, thank you very much.
All right, any follow on? Okay, next slide is about populating the copper backplane, what I call the backplane. What you see up there first is a polyphaser, and I'm partial to polyphasers because they do the job quite well. And basically what you want to do is think about how you're going to bond all your wires to your copper backplane inside the box. So you've got wires, you might have round wires like the green one. You might have braided wires like in the picture below it. And you also might have another type of wire, which is just basically pure copper strapping. But basically you're going to use bonding lugs to be able to connect those wires to your backplane. The bonding lug is just a method of attaching a terminal to the backplane via a fastener. And in this particular, in the upper left corner, you'll see a copper bonding lug. It's got a set screw. You screw out the set screw, you loosen the set screw, put your copper wires in there and crank down on that set screw, and it makes a mechanical bond between your backplane and the wire. Also in this particular picture, you also have a gang, what we call a gang bonding lug, or just a gang lug. It's a way of using one lug that's just got 5 screws on it. You bond that to your backplane using fasteners. Now all of a sudden you've got the ability to use 5 fasteners to install your copper wire or your braided wire to the grounding plate that's inside your service panel. What's next is your rotor control wire. That's the other type of wire that you're going to have out on your tower, right? Or your telephone pole, whatever you're using. This is a simple 8 conductor plus ground wire. And those you're going to feed into a terminal block. The one that I have pictured here is a 12 position terminal block. One side is going to have the control wire coming from your rotor. The other side is going to be connected to another rotor control wire that goes to the control head inside your station. What's also going to be connected to those are metal oxide varistors. These are protective devices designed to protect the line from an excess or a surge in voltage along that line. So you're going to need one for each wire. In this case, you're going to need at least 8 of these connected on that terminal block. One side's going to go to ground. They all get tied to ground on one side of the MOV. The other side, each individual line or each individual terminal gets its own metal oxide varistor. And the way they work is, a metal oxide varistor is a variable resistor. It conducts voltage to ground. Assume that you're connecting it to ground beyond a certain voltage. And this particular limit is 130 volts. That red one that you see in my my slide is rated for 130 volts, which means anything above 130 volts is going to get conducted to ground. And certainly a lightning strike would probably be well above 130 volts. And I'm sure that MOV would do its best job possible trying to conduct all that voltage and current to ground. It's going to get destroyed in the process, but probably save a human life in the meantime. This is K1RCT. Any questions about MOVs or grounding and populating the copper backplane? Okay, nothing heard via Zoom or 2-meter. I've also got in this slide a cross section of what makes up a metal oxide varistor, just for fun. So these slides will be made available on YouTube. I am recording this, and eventually the YouTube video will be up so you can review this at your leisure. On to the next. Okay, polyphasers, or lightning protection for the coaxial feed lines. This slide depicts 4 different type of devices that are designed to protect coaxial lines or feed lines, coaxial feed lines coming into your shack. The upper left is what we use at the EOC, but there are others. There are others that have different device ratings, wattages, and abilities. The one in the upper right corner is designed for DC to 2500 megahertz, 400 watts, and can discharge DC voltage up to 350 volts. What's important here is to understand that there are 2 ratings, essentially 2 ratings, maybe 3, that you need to consider when selecting coaxial lightning protection for your shack. The first is your bandwidth. What bands do you intend to protect? What are you protecting? Are you VHF, UHF? Is it HF? As you can see in the upper left with the polyphaser, it's rated from 50 to 220 megahertz at 375 watts and 220 to 700 megahertz at 125 watts. So certainly not for some station that's got a pretty pretty hefty amplifier and certainly not for the HF bands. The one in the upper right is DC to 2500 megahertz are certainly the HF bands and VHF UHF bands, 50 ohms and up to 400 watts. The point of all this is to understand that there are ratings you have to observe. And why do you need DC pass or DC block? Because if you're, let's say you're going to be putting in 5 towers or 6 towers, and you're putting in a halo grounding system in a complicated system, you may be using a remote antenna switch, which uses DC voltage passed along your coax, which yes, you can do. So you need special devices to be able to pick that voltage off to be able to select different antennas, but you can use it. So when you use a lightning protective device with a, let's say a remote antenna selection system, you're going to need something that passes DC voltage, something along the lines of 12 volts, maybe 24 volts. I'm not sure, but you're going to need a DC pass. And a lot of these are DC block. Obviously, you probably figured out already, one is probably more expensive than the next. That's the way it is in life. This is K1RCT. Any questions about polyphasers or lightning protection for your shack?
Hey, Rob.
Yeah.
I was up for a second. Sean N1, KC1NQE had a post in the chat. I don't know if you saw it, and it might have been from a year or two ago, but he asked about for home setups, would making a separate ground set for antennas or tying it to the existing house ground be recommended, and does it make a difference?
Yeah, so the answer to that is yes. You need to ground your house ground that comes in from the street. Whatever ground they use, that needs to be grounded to the single point ground of your shack. Everything needs to be tied to that in the single point ground system. And obviously the reason for that is the protection of human life. No one thinks for a second you're going to be able to protect your gear from a direct lightning strike, no matter what you've got connected to it. If your coax connector is connected to that rig and that thing sustains a hit from a lightning strike, you're not going to protect that. What you want is to be able to protect human life from somebody that may be operating that gear. You want to protect that human life and conduct that voltage, provide a shorter path to ground for that lightning that's outside of the building versus inside of the building. You may not protect your gear as long as you protect your life. And yes, that includes the ground that's brought in from the street. That's the way we did it at the EOC, and that's the way it should be done, in my opinion, everywhere. Hopefully that answers NQE's question.
Yeah, I would hope so too, and I apologize for not picking that up on the chat point sooner. I was slightly distracted from one, but great presentation. Keep at it. Not a problem. I'm grateful for questions. Ted, did you have a question?
Yeah, just an observation. When you know that there's lightning coming, you know, you've got advance warning of a storm, I find it's a good idea. First off, stay off the air, but unplug your equipment from the lines and disconnect your antennas. And then I also have a connector that takes my antenna in and directly grounds it. You know, so my antenna is safe. If anything hits, goes straight through the ground, protects my equipment, protects me, hopefully protects my house too. But I mean, it seems obvious, but you know, it's just something worth mentioning again.
Okay, that was a comment from Ted KC1DOY, and he made an astute observation about protecting your equipment by disconnecting the feed line and possibly the electric service from your rig when there's a known electrical storm in the area, and that's absolutely 100% correct. That's the absolute hands down best way to disconnect your feed line and then ground it so that there's no chance of an arc. Because even an arc from the center conductor to the ground, which will happen if there's a direct strike, will obviously damage your coax and the antenna and some other stuff if it happens to be in the area. So grounding it exterior to your home is the best way possible to protect your rig and protect your life. Any other questions? This is K1RCT. Moving on. Okay, we'll move on. What's inside? Now I'm going to go back for a second, just to show you guys looking at my slides. The rightmost two protective devices have this little stud coming from the top one has a stud on the bottom one has a stud on the top. What's next is what's inside that little stud. Now in those two devices, you can actually change out your gas discharge tube. That's how the protection actually occurs. There's a gas that's inside this little tube, and when it senses a voltage that is beyond a certain limit, it starts conducting that voltage to ground, and the thing lights up like a little light. If you happen to be in the area when the lightning strike actually gets to one of these little tubes, it glows brightly, and you probably don't want to be anywhere near the area if that's happening. But this is how they do it. And on some of the devices that you can purchase, you can actually replace them. There is a maintenance cycle for these things because you never know how many of these little lightning strikes you may get at a particular station. You're not always at your shack. You never know when you're actually getting a storm in the area. We sustain maybe not a direct strike or maybe an off-center strike. And some of these things actually get a little worn and they may need replacing over time. So it's nice to be able to change them. Any questions about gas tube discharge? Is K1RCT?
Rob, I did actually these. I did some reading on these, and I remember reading what you just said that they it should be replaced. So I was just curious if they've been struck. I guess they're kind of like a fuse in some ways. If they get struck, they need to be replaced. So what happens if you don't replace one and it did absorb a lightning strike? Is it like an open circuit? Do you just not have the lightning protection? Is your gear then at risk? What would happen if you don't replace the gas tubes?
Okay, that's a great question. Okay, the question is coming from Zoom. What happens if you don't have a maintenance cycle or you don't replace your gas tube discharge devices inside your coaxial protection devices? The short answer is, yeah, if it sustains a hit or if it sustains a little bit of a voltage hit, you could consume the gas that's inside, pardon me, or you could completely damage the device, which then at that point no longer provides any protection for the coax that it's serving. So you have no parallel path to ground, in other words. Some radio amateurs that have, let's say, maybe they've got a lot of towers, and there's a few call signs that come to mind. I won't mention them, but sometimes they make these homemade arc devices. Basically, it's a welded device that's in contact with the tower and another welded device that's in contact with the ground rod. And they're very close proximity to each other, and they're designed to arc over when there is high voltage present from the tower to ground. And basically it acts like the same thing as this gas tube discharge device, right? These are simply more convenient way to protect your coax feed lines, excuse me, from high voltage surges and lightning discharges. Any other questions? This is K1RCT.
The old timers use spark plugs.
Yeah, spark plugs are another method. I was going to talk about that. I thought I heard somebody else making a comment. Was that directed towards Annette? Okay, nothing heard. Nothing heard, so we'll move on. The next, grounding rods. Ground rods come in 8-foot and 4-foot sections, maybe some others. There might be some 2-footers out there. Which to use depends on your own soil conditions like moisture. Especially dry soil may require deeper rods or a halo system. What I've got up on the screen now are just a few different types of grounding rods and a few different applications for those. Pardon me. Most grounding rods aren't true solid copper rods. They're actually steel that have been flashed with copper. Flashing is a method of plating other metals with a very, very thick coating of whatever it is you want to flash it with, usually copper in this case. But as you can see in the center picture, there's a steel rod that's got some rust on it. So you know it's made of steel, but it's got copper on the outside. What system you have to use? I've also got up on the screen a little cross section of a theoretical backyard section of earth. That is approximately 24 inches deep. Now, I don't know of any rods that I've ever come across that are 2 feet deep. Most of the rods I come across are 8-foot sections. But I suppose if you find that you only need 24 inches of rod to get to damp earth or highly conductive earth, then that's all you need. I know in my backyard, I need at least 6 feet down. I've got really, really conductive soil. And that's what I use. I use an 8-foot rod to get down beyond that 6 foot. And that makes a solid conductive grounding rod for myself. How would you know what you need to use? Well, there's several methods. You can use the DEEP website, which has got some information about soil conductivity in your area. You can consult with the Agriculture Cooperative Extension of a local university or college and ask them the same question. There are several resources that you can find for determining how deep you need to bury a rod to get to conductive soil. But the purpose of this whole thing is you need to know. You don't need to guess. You need to know. So you should find out. And there are ways to find out. Okay, station identification. This is K1RCT. Any questions about grounding rods? Nothing heard, we'll go on. The connections you make to your grounding rods are as important as the ground rod himself and the wire that you use to get there. What you see up on the screen are different methods of connecting a grounding rod to a wire. Okay, what wires are we talking about? On the upper left, upper right corner is copper strapping. That's my favorite method of connecting a ground. It's thick, it's 100% copper, conducts a lot of current if I need it to. In the middle, you have what's known as copper hanging strap. Basically, it's steel strap that's been flashed with copper. It's got holes perforating it that you can use to hang copper pipe in your house or in your establishment, and it also is a good conduct to ground. On the lower side, on the lower right, you have some copper braided wire that's been flashed or tinned in order to facilitate soldering to it if you need to. From all of these, you're going to need to be able to bond this to your copper plate, your backplane, and to your grounding rod. And you do that through wire terminals like on the lower section that you're looking at my screen. Those wire terminals are how you bond let's say a copper braided wire, or even if you punch a hole into the copper strap, you can certainly put a wire terminal on there and connect that, bond that to your copper bonding plate. There is another method for bonding wire to your grounding rod, and that's called Cad welding or cadmium welding. Basically, if you buy a Cad kit, they're going to give you a graphite crucible, which will allow you to connect a copper wire to a copper grounding rod, fill it with cadmium sulfate or some sort of other cadmium medium, and then hit that with high temperature propane torch, and it will actually weld the two articles together in a permanent connection. That's probably the preferred connection you want to make if you're installing more than one antenna system or a series of towers on your property. This is K1RCT. Any questions about rod connections or how we connect those up?
KC1DOY.
Go ahead, Ted.
I just wanted to point out the rod connector, like the one you see in the upper left hand, that screws on over the rod. If you're like me and use the brute force hammered into the ground method of putting in your ground rod, put that connector on the rod first because you may flatten out the top of the rod as you're hammering it, and that won't want to slip down easily anymore. So although you can kind of file it down later, it's easier to put that on first and then put the rod in the ground.
Okay, that's probably true. There was an observation on the Zoom deck for making sure that when you're driving your grounding rod in there, put the connector on first, because you may mushroom the top of the grounding rod, and now your rod connector won't fit over the top. You're going to need to take a grinder to it just to get it on there. So that's probably good advice.
WA1TRY.
Hey, Rich, go ahead.
Yeah, I read recently in the latest ARRL grounding issue book they came out with, and the common idea these days is not to use the braided tinned type of cable that you see down in the left center there. For outdoor connections, they work fine indoors or where there's not much moisture. I used to use that for my towers all the time, and I had some really hefty stuff, about 4 inches in diameter, and folded flat, and that's what I've always used. And when I moved, I took that all down, and I took a hacksaw and cut it in half, and the interior of it was all rusted. And so I checked with the ARRL, and they said they really frown on using that braided stuff outside in the weather, because if you get a lightning strike and that thing's been compromised interior, the copper is corroded interiorly, it's going to blow that thing right apart.
Yeah, I would agree with that 100%. So the observation was on the Zoom deck was using copper braided wire on an exterior connection to ground. And I have to agree, that was from Rich, WA1TRY, and that, as the ARL points out, it's probably not a good idea to use copper braid on the exterior exposed to the elements. I use copper braid for interior connections. When we come from the electric service panel or from each piece of gear, it's using a copper braid that's inside and fairly well protected from the elements. Exterior, I use solid copper or copper rod, and that's probably really, really good advice. Any other questions? This is K1RCT. Coming to the end of it. Okay, we're going to go over recap. The recap is determine requirements. When you're putting in your single point ground system, you need to consider your antennas, your gear, the location, your positioning. Number 2, read the NEC code for transmitting stations. It's very short, but essential to understand. Excuse me. You should make a list of everything in your station that will need protective earth ground. You should develop a list of stuff to buy or otherwise procure. Hamfests, eBay, tag sales, QRZ.com, HomeQTH.com are all excellent sources. And yeah, sure, engage your scavenging skills here, because you don't always necessarily need to buy things. Sometimes you can barter things, and I'm a firm proponent of bartering services with each other to obtain the resources you need to do this kind of stuff. I'm probably getting ready to lose this battery on this HT2. Okay, so figure out where you want to install your SPG entrance and how to secure it. Next is, when designing your panel, leave room for future expansion and repairs. I mentioned somewhere in these slides that the EOC is right now accommodating 5 antennas. It can probably accommodate up to 3 more, including all of the coaxial protective devices, probably another rotator if we need to put one on there. So leave room for future expansion. You don't want to have to redesign something just because you want to put another antenna up. Use glands and seals on your panel. Leave no open holes anywhere. This will keep moisture, mice, and bugs out. How nasty would it be to open up a service panel only to find that you've got a hive in there, or something worse like a mouse that, you know, started chewing on your stuff? You don't want that. So use glands, use seals. Make sure you seal that thing up from the exterior elements. Next is, remember you're working with copper. Use an antioxidant on each contact with the copper backplane. Copper will tarnish very fast in the elements. So if you do a good job sealing up, also use a little bit of like copper antioxidant grease that will help to preserve the connection going forward. This K1RCT. Last two, run all lines to and from the SPG entrance. Do not forget to bring electric service ground to the SPG. Don't be tempted to daisy chain your ground runs. Each device should have its own PE connection to single point ground. That being said, make sure you ground everything. Bring it out to that ground. Lastly, drive your ground rod near to the single point ground entrance. Use heavy copper to connect it. This is a good application for Cad welding. I have never done Cad welding, but I understand its implication. It's probably the best way to secure like a halo system like we had at Cook Hill. I think Rich, you told me there was a halo system installed there, which is all the way around the building. It's a good way to protect human life. Any questions on anything we've covered so far? This is K1RCT.
K1LYP.
Hey, John, how you doing?
Good. In your presentation, which I have to comment on, is very, very educational and very precise. The one thing I was wondering if you were going to bring up is the fact of checking around your water meter that you do have a good ground if you're grounding to a copper pipe in the home, which many people do, and finding out that they have not put the jumper in across the water meter if you wanted to address that.
Yeah, that's probably a really good idea. I wasn't planning on going into that for here. I wanted to leave some room for expanding on future grounding problems. But yeah, that's a really great idea. And like at the EOC, and I know you've been in that same room that I have, they use the water system for grounding there. And yeah, you know what? I never checked that. I never checked to see if they've made sure that they paralleled that water meter, but that's a good point, John. Any other questions?
KC1DOY.
Go ahead, Dad.
Yeah, I just wanted to mention, if you have a newer home, you may find that they do not use the copper pipe anymore. They're using PEX, which is, what do you call it?
Plastic.
Plastic. So you're not going to find a direct route to ground to the pipes. You may also find that you have copper pipes in the house that are connected to PEX somewhere else along the line, especially if you've done remodeling and things. So always be sure, if you're going to use your copper pipes, your water pipes, make sure they really do go all the way to ground and there's not something in between that breaks that connection, because it's quite possible you might find it if you've done any changes.
Yeah, so in my own home and at the EOC, all of the copper service is done before the meter. So if you're using ground, and this goes to having knowledge and not guessing about your own situation, you need to investigate your own self, what's available to you. If they're grounding via copper pipe entrance to your building and then bringing that over to your circuit breaker panel, you need to understand that you should bring that ground as it comes into your building on the copper pipe all the way out to your single point ground by its own separate conductor. You need to bypass any other connections there and understand that you're just trying to protect human life. You're trying to protect your gear as much as you can, but human life is where you need to live. And you need to understand your own application so that you know how to proceed. And that's a good observation, Ted. Thank you for that. Any other questions or observations to this time?
And one GNB.
Hey, John.
Just as Rich kind of touched on a little bit, ARRL has a great book ARL has an amazing amount of technical information. If you don't belong to the league, you really should. There's an amazing amount of technical information on their website that they do a great job of not letting people know about. But other than that, Ward Silver and Zero AX, very, very knowledgeable guy. He wrote the Bible on this, and it's been out for a few years, and it's grounding and bonding for the radio amateur or something like that. Bonding and grounding and bonding for the radio amateur. But if you're going to start down this path, Ward Silver's book is highly recommended. And as always, don't ask technical questions on Facebook. Don't ask technical questions on Facebook. Don't ask technical questions on Facebook.
Okay, I think we need sorry for the 2 meter long lapse of transmission, but we had a few questions on Zoom, and mostly it was observations about how bonding to ground happens in your home, and how not to ask technical questions on Facebook. And I agree with that wholeheartedly. That's a good point, John. All right, I'm going to proceed. Resources, and you'll find some of that very I don't see the N0AX in my stuff. I probably didn't come across his article, but I do have radio grounding and bonding for the radio amateur, which is an ARL publication. These are all resources that I used in researching for the EOC in my own home and for this presentation. And it's available. It's going to be available on YouTube directly from me if you want a direct link to the video. But these are some of the resources I used, and they can do you well in designing your own single point grounding system for your antenna system.
Just a quick point. That book that you mentioned, Ward Silver, he's in N0AX. Grounding and bonding for the radio amateur is his.
Okay, so N0AX is represented here. I just don't have a link for it because that's on the ARL website as something that you should buy. And I have a copy right here on the desk, right behind this computer. So yes, it's a great book. I agree. Okay, so the other thing that you should think about understanding, and what I'm reviewing here on Zoom, is NEC for transmitting stations. NEC stands for National Electric Code. And the specific revision is 2011, Article 800 applies to amateur radio communication systems, Article 810. And there are 6 bullets that you should familiarize yourself with under Article 810 for transmitting stations. This is all referred to grounding. Basically, all of this is designed to protect human life, to conduct the shortest path for electricity to ground outside of the building rather than inside the building through humans or gear or transmission lines or control lines. All of that stuff is done on the outside, which is the point of the single point ground system. And that's my entire presentation. Is if you've learned nothing, you should a little bit know at this point how you should go about educating yourself on how to ground your station. Are there any questions before I proceed? This is K1RCT.
K1LYP commentary.
Go ahead, John.
I don't know if you brought it up there, but the last line of what we're looking at over here says that shall be no less than 14 AWG copper as the grounding conductor. Obviously, I like something a little bit heavier, but 14 is the minimum. And as with anything that's minimum, if you can exceed code, go the next size up.
Yeah, no doubt about that, John. I like 12 gauge wire. All my extension cords that I personally own are 12 3s. And for the same reason, because they conduct a little more electricity, and they can conduct more current, and especially 14 gauge is kind of small. but that's NEC code, so I wanted to quote it. But yeah, there's no reason not to exceed specification. Grounding wires should be 6 gauge, 8 gauge kind of stuff, because you potentially are conducting a lot more current to ground than the standard of service that's coming into your building. Any other observations or questions before I proceed? Nothing heard. C'est la fin. That's it. That's all I got, guys. Any questions before
Excellent
we close
job.
the net?
C'est bien.
C'est
Excellent
bien.
job.
Très bien. Très bien.
Très bien, très bien.
Très
Merci.
bien.
Merci, mes amis. Nous allons.
C'est good.
Wonderful. Wonderful, Rob. Great, great net. Thank
All
you.
right, I'm going to close out on the 2 meter. So
Sounds good.
we can stand by for a sec. This is K1RCT closing the Meriden Amateur Radio Club TechNet for February 18th, 2021. Are there any questions or comments before I close the net?
Nice job, Rob.
I thank you all for listening in. Those who have stayed by the 2 meter repeater, and return the W1KKF repeater to regular amateur use. This is K1RCT 73.
Hey, Rob, nice job.
Nice job.
Thanks, guys. I appreciate that, Bill. I appreciate it, James.
Good
You
night,
know,
all.
I just remember, all I really wanted to do is just wet your whistle to ask questions and maybe get you thinking about your own situations at home there, and maybe protecting yourselves a little bit better.
Very good job, Rob.
Thank you.
Thanks, Rob.
All right. How many attendees did we have, James? I didn't get to count.
You were at a high of, I saw it up to 30 at one point, and you hung in around 28 through the whole night. So that was pretty well attended. The Zoom thing is working out pretty well for us.
Yeah, I kind of
So,
like the platform. I'm happy with the platform. I'm happy we saw Ant
Yeah,
and some of
Ant's
the
up
guys
in 2
from.
weeks.
Go ahead.
Yeah. I've been trying to cross promote it on the Facebook, on the Connecticut Ham site. People comment on it. I think we are getting some folks to stop in. And it's working well, I think. You know, we're starting to feel our way, and we're getting good turnout. We're averaging about, I think, 30 people per net, and this was an outstanding one, a good quality tech net. So
I appreciate it. Yeah, I'll get this thing up on YouTube as soon as I can. And now that I've come back to the real world, I see some 5 questions. Where do you buy glands? And
yes,
water pipes should never be used. Yeah, I agree. Home setups, separate ground site for antennas. Yeah, these are all questions. These are all valid questions I can answer at a later time, but write your questions in the chat window. Yep. Cool. All right. Well, I think we got a
I
successful
gotta blow out of here.
All right. Well, thanks,
Yep.
James.
Ant's up in 2 weeks. Ant's doing satellite ops in 2 weeks, and then we're gonna have a TechNet trivia game 2 weeks after that. So a couple of interesting ones coming up too. But this was great. Thank you so
Awesome.
much.
All right, James. Thanks a lot. Thanks for
Night,
attending.
everybody.
guys.
I gotta blow.
Take care of yourselves.
Yeah, I'll catch you guys next time. Be well. Good weekend. All.
Yeah. Have a great weekend. Stay out of the cold air.
Nice job there, Rob.
Thank you, sir.
Okay, good night, 73 all.
See you, Ted.
Excuse me, Don Goin, K1CMM.
Hey, Don.
Is anybody familiar with the iPad? My camera is pointing away from me.
There should be a little device on your screen that looks like a reciprocal arrow, like 2 arrows pointing at each other. You should be able to hit that and change the angle of your camera from back to front.
I don't see. I don't see it. I don't see. Switch camera.
Yeah, try that.
Okay.
I see you pounding that thing, and I don't think it's working.
It's not changing it. It keeps is looking at the computer on the other side of the thing.
Right.
And it comes, I got to pull this thing down at the top every time and it disappears and it doesn't come down easy.
Ah, that's probably why.
Whoop, now I lost it completely. Boy, this is fun. I just love computers. It says,
I sense the sarcasm in your voice, Don.
yeah, it says switch camera, and it has a little camera with arrows rotating on it.
Yeah, that should switch from front to back or back to front.
I've tried moving it, and I've tried tapping it, and it says, boy.